It was October 3rd, 2025, and while most of the world was busy scrolling through their phones or binge-watching the latest reality show, I found myself glued to the feed from the British Mars orbiter. The probe had been circling the red planet for over 4 years, its main mission long done, but now it was chasing something far more mysterious, an interstellar visitor that had crashed our cosmic party. They called it Comet Sutton. Not the most glamorous name, but hey, it beats Object 2025X. This thing was moving at a staggering 58 kilometers per second, about 129,000 miles per hour. To put that into perspective, you could zip around Earth's equator in just 18 minutes. And yet, Sutton was only about 3.5 miles across, roughly the width of my hometown's Main Street, and a whopping 18 million miles away from the orbiter's camera. The Brits didn't announce their plan to track it until they had the images ready, and when they finally did, the pictures were, well, confusing. Instead of the dramatic comet tail streaming behind it like a celestial firework, Sutton looked like a fuzzy white blob surrounded by a faint, ghostly glow. No tal. No streaming debris. Just silence where there should have been chaos. If comets were rock stars, Sutton was the guy who showed up to the gig in sweatpants and a hoodie. Definitely not what anyone expected. Now, I'm no astrophysicist, but even I knew this was odd. You see, when a comet like Sutton gets close to the sun, the heat should vaporize its icy surface, creating that bright, trailing tail. Sutton passed the sun at about 0.9 astronomical units, closer than Earth to the sun, and yet it lost an estimated 13% of its mass during that close approach. That's like shedding 4 billion tons of gas and dust in just days. Normally, that kind of loss would paint the sky with a spectacular tail stretching millions of miles. Instead, nothing. This was the first of 10 strange behaviors Sutton displayed. 10 separate anomalies that made scientists scratch their heads harder than when they tried to explain cricket rules to Americans. Each anomaly was rare by itself, but all combined, the odds were less than 1 in 10,000. Not impossible, but definitely eyebrow-raising. And so, I found myself diving deep into the data, piecing together the story this lost comet, or whatever it was trying to tell us. The trajectory alone was weird. Sutton's path was almost perfectly aligned with the plane where all the planets orbit, but it was moving backwards compared to them. Imagine a car driving the wrong way on a busy highway, but sticking exactly to the lane lines. The odds of that happening by chance? Slim to none. But Sutton wasn't just breaking speed limits or traffic laws. It was shooting a jet of material toward the sun, defying every known law of physics and common sense. It was like trying to blow smoke into a hurricane and having it blow back at you. No natural comet behaves like that. Then there was the chemistry. Spectroscopic analysis showed Sutton had more nickel than iron, opposite of what we see in natural comets, and only 4% water content. Comets are supposed to be mostly frozen water. Sutton was barely icy at all. It was more like a metallic rock with a dusting of frost. The brightness surged insanely fast and shifted toward blue hues, unlike any comet we'd ever seen. And despite all this mass loss, there was no tail, no dust clouds, no debris, nothing where there should have been a spectacular display. Scientists debated. Could it be a trick of perspective? A fluke in the data? Sure. But stacking all these unlikely quirks together? It felt like Sutton was less a comet and more a cosmic enigma wrapped in a riddle, sprinkled with a dash of wait, what? The more I looked, the more I realized this wasn't just about a space rock. It was about how we approach the unknown. Are we ready to admit that sometimes the universe throws us a curveball so strange we don't yet have the tools or the courage to fully understand it? As Sutton sped away from us, fading into the void, I couldn't help but wonder. Was this just a freak of nature? Or was there something more? Something deliberately designed? Something sent? And just when I thought I'd seen all the surprises Sutton had to offer, an encrypted message popped into my inbox from a young astrophysics student in Cornwall, inspired by Sutton's mysteries to chase the stars herself. The comet was gone, but the questions were just beginning. And somewhere out there, drifting through the dark, I had a feeling Sutton wasn't the last visitor we'd see. Something else was coming. Something that might finally force us to face the biggest question of all. Are we truly alone? By early November, as Sutton drifted farther from the sun, The observatories across England and Europe trained their most powerful telescopes on it, hoping to catch the comet's farewell performance. Instead, they got another surprise. The images showed a compact, misty sphere, still fuzzy, still tailless. The direction the tail should have pointed? Absolutely nothing. It was like expecting fireworks and getting a fog machine. I remember staring at the screen in my cramped office in Cambridge, nursing a cold cup of tea that had long since gone lukewarm, thinking, right, Sutton, you're officially the universe's biggest tease. No tail despite huge mass loss. It defied every rule in the Comet playbook. The missing tail was anomaly number 10, the final piece in a puzzle that just kept getting stranger. Now, Sutton wasn't just ignoring cosmic etiquette, it was actively breaking the rules. Take the sunward jet phenomenon, for instance. Normally, when comets eject material, it streams away from the sun, pushed by solar radiation like leaves on a gusty autumn day. But Sutton was spewing material toward the sun, like some rebellious teenager sneaking back into the house after curfew. And not just a faint trickle, multiple teams confirmed it was a real jet, not an optical illusion or a trick of perspective. Scientists scratched their heads, ran simulations, and double-checked their instruments. Nothing mundane explained this. It was as if Sutton had its own agenda, pushing material in defiance of physics. And then there was Sutton's trajectory, an absolute showstopper. Its orbit was nearly perfectly aligned with the plane where all the planets circle the sun, but it moved in the opposite direction. Imagine a cyclist on a one-way street, pedaling furiously against traffic but never veering off course. The odds of an interstellar visitor arriving just like that? 1 in 500. Not impossible, but suspicious enough to make you raise an eyebrow. But here's where it gets even weirder. Sutton's arrival was perfectly timed to visit Mars, Venus, and Jupiter, all while their orbiters and probes were actively watching. It's like it planned a tour through the solar system's major observation decks, but somehow managed to avoid being seen from Earth at its brightest point near the sun. The probability of that timing? About 0.005%. If Sutton had a business card, it would say, Master of Cosmic Hide and Seek. The composition was equally baffling. Spectral analysis revealed a nickel-rich makeup, far exceeding iron levels, more like the alloys used in spacecraft construction than natural space rocks. And water? Just 4%. For comparison, typical comets are mostly water ice, 70 to 80%. Sutton was barely frosted, more like a cold, metallic pebble dressed up as a comet. I couldn't help but joke to my colleagues. Maybe Sutton's just a cosmic hipster, too cool to be an ordinary comet. But jokes aside, these anomalies stacked up like a detective's case file bursting with contradictions. Even the way Sutton reflected light was off. Its surface polarization was completely unlike anything recorded in thousands of comet observations. The light bounced off it in a way that suggested a surface made of materials and structures we simply don't understand. Amid all this, a buzz started building in the scientific community. Was Sutton a natural oddball or something else? Some whispered about artificial origins, but most dismissed such talk as science fiction. Still, the questions lingered, gnawing at the edges of conventional thinking. Then came a message that added a human element to the cosmic mystery. An email from a young woman named Emily Hawthorne, an 18-year-old from a small town in Devon. She wrote about how Sutton's strange story had inspired her to consider a career in astrophysics, a field she'd never thought about before. Suddenly, this wasn't just a distant space rock. It was a beacon sparking curiosity and wonder. As I shut down my computer that night, the image of Sutton, a ghostly, tailless comet defying every expectation, lingered in my mind. It was a stranger in our cosmic neighborhood, slipping quietly away but leaving behind a trail of questions that would haunt astronomers for years. And somewhere out there, beyond the reach of our telescopes, I suspected another visitor was already on its way, ready to up the ante and challenge everything we thought we knew. But for now, Sutton was fading into the dark, its secrets intact, daring us to catch up. The morning of November 15th dawned cold and clear over the quaint village of Whitby, nestled along England's rugged Yorkshire coast. I found myself standing outside the Whitby Observatory, a small but passionate outpost that had been instrumental in tracking Sutton's bizarre journey. The air smelled faintly of salt and damp stone, and the faint hum of the telescope's motors was the only sound breaking the silence. Inside, Dr. Jessica Clark was preparing for another round of observations. Jessica was the kind of scientist you'd picture in a vintage detective novel. Sharp eyes behind thin-rimmed glasses, her auburn hair pulled back in a loose bun, a scarf loosely draped over her shoulders despite the heater humming nearby. Today, she wore a tailored navy blue blazer over a soft cashmere sweater, paired with dark jeans and ankle boots that clicked confidently on the tiled floor. There was a subtle elegance in her demeanor, a quiet intensity that made you think she could solve cosmic mysteries and still make time for a proper cup of tea. Jessica had been leading a team analyzing Sutton's light polarization, the way sunlight scattered off its surface. It was one of the stranger anomalies, showing extreme negative polarization unlike any comet before. The data suggested a surface texture unlike anything natural, with particles arranged in a way that baffled current models. "Morning," I said, stepping inside and shaking off the chill. "Any new revelations?" Jessica smiled, a mixture of excitement and frustration. "It's like Sutton's playing cosmic dress-up. The polarization patterns suggest a surface that's engineered almost, not like the random dust and ice we'd expect. If this were a crime scene, I'd say someone left fingerprints." I chuckled. "So, you're saying Sutton's a galactic prankster?" "Maybe," she replied, eyes twinkling. "Or maybe it's a message. Something designed to stand out, to make us look closer. But the more we analyze, the more questions pile up." We pored over the latest spectroscopic data, revealing the comet's unusual chemical makeup, nickel-rich, low water content, and a strange abundance of cyanide compounds. The ratios resembled industrial alloys more than cosmic ice balls, hinting at a formation environment unlike anything in our solar system. Jessica leaned back, swirling her tea thoughtfully. "If Sutton's natural, it's from a star system with chemistry that defies everything we thought we knew. But if it's not, well, that opens a whole new can of worms." I nodded, suddenly aware of the quiet intensity in the room. This wasn't just about astronomy anymore. It was about confronting the unknown, about being willing to question everything. Outside, the wind picked up, rattling the old observatory windows. Jessica glanced toward them, then back at me. "You know, if Sutton were a spaceship, it's the worst one ever. No shiny hood, no blinking lights. Just a fuzzy, uncooperative blob." I laughed. "Maybe it's the cosmic equivalent of a rust bucket. Falls apart under pressure but still manages to surprise." She smirked. "Well, whatever it is, Sutton's taught us one thing. The universe doesn't do neat and tidy." As the telescope began tracking the distant comet again, I felt a chill that wasn't just from the cold. Sutton was slipping away, but its strange story was far from over. And in the distance, beyond even Mars's orbit, something else waited. Another visitor. Another mystery racing through the cosmic dark, ready to challenge everything we thought we knew. The game was just beginning. Late one foggy evening in the sleepy town of Ashford, I found myself wandering the narrow cobbled streets, the glow from gas lamps casting long shadows that danced like ghosts on the damp stone walls. The quiet was broken only by the distant hoot of an owl and the soft crunch of my boots on the wet pavement. Ashford wasn't exactly London, but it had its charms, and tonight it was hosting a very different kind of gathering. Inside the local pub, the Silver Lining, a small crowd had gathered, not for pints or gossip, but for a live webcast featuring Dr. Marcus Bennett, a jovial but brilliant astrophysicist from the University of Cambridge. Marcus had a knack for making complex science sound like a thrilling mystery novel, and tonight he was explaining the latest baffling anomaly of Comet Sutton. Its non-gravitational acceleration. Marcus, with his tousled sandy hair and a crooked grin that suggested he knew more than he let on, stood before a chalkboard covered in equations that looked like a math teacher's nightmare. He was dressed casually in a checked shirt rolled up at the sleeves, dark trousers, and a pair of well-worn brogues that clicked as he paced the stage. "The comet is being pushed," he explained, waving a hand dramatically. Not by gravity, not by solar winds alone, but by something else. It's like Sutton has a hidden engine, nudging it along at nearly 129,000 miles per hour. A murmur rippled through the crowd. I leaned forward, captivated. But here's the kicker, Marcus continued, eyes sparkling. For Sutton to accelerate like that, it must have lost a mind-boggling 13% of its mass in just days near the sun. Yet where's the trail? Where's the debris, the glorious tale we expect after such a cosmic shedding? It's as if billions of tons of material vanished into thin space. Poof! He paused, then grinned. Maybe Sutton's got a cosmic magician hiding inside. Or perhaps it's just really good at hide and seek. The room chuckled, but beneath the laughter was a palpable sense of awe. Sutton was rewriting the rulebook. Later, as the webcast ended and the pub's chatter returned to everyday matters, football scores, the weather, local scandals, I lingered by the window, staring up at the clear, starry sky. Somewhere out there, Sutton was speeding away, a puzzle wrapped in a mystery, refusing to yield its secrets. I pulled my coat tighter against the chill and thought about the timing of Sutton's journey. It had passed Mars, Venus, and Jupiter just as their orbiters and probes were watching. Almost too perfectly timed to be coincidence. It was like the Comet had RSVP'd to a cosmic party and knew exactly when all the guests would be home. That thought sent a shiver down my spine. Walking back through the foggy streets, I couldn't shake the feeling that Sutton's story was far from over. And as the night deepened, I wondered what other secrets the universe was hiding, waiting for us to look up, to question, to discover. Because if Sutton was the opening act, the main event was still on its way. The day dawned misty over the sleepy market town of Stratford-upon-Avon, the birthplace of Shakespeare and, on this particular morning, the unlikely stage for a high-stakes scientific debate. I found myself seated in a cozy corner of the local library's reading room, surrounded by leather-bound volumes and the faint scent of old parchment. Across from me sat Professor Henry Caldwell, a distinguished astronomer with silver hair and a meticulously trimmed beard, his deep-set eyes twinkling behind round spectacles. Henry had been one of the first to study Sutton's unusual chemical makeup, and his insights were as sharp as ever. He wore a tailored tweed jacket over a crisp white shirt, a patterned silk tie knotted just so, and polished brogues that tapped rhythmically on the wooden floor as he spoke. Water content at 4%, he mused, swirling his cup of Earl Grey. That's not a comet. It's more akin to an asteroid, perhaps even a metallic body cloaked in frost. But the high nickel-to-iron ratio, astonishing. Industrial alloys, not natural cosmic ice. I raised an eyebrow. So what does that mean? Are we looking at space debris from some advanced civilization? Henry chuckled, but there was an edge of seriousness in his tone. We can't jump to conclusions, but Sutton challenges every assumption. The trajectory alone, aligned nearly perfectly with the ecliptic plane yet retrograde, is improbable. Then the timing of planetary flybys. It's almost as if it planned its path. I leaned forward. You don't think it's just a lucky coincidence? Luck. Henry smiled dryly. In my years, I've learned the universe rarely hands out such gifts without strings attached. Either Sutton is a freak of nature, or it's something else entirely. We spent hours poring over spectrographs, trajectory plots, and polarization data. The more we analyzed, the more Sutton seemed less like a comet and more like a cosmic enigma wearing a disguise. Later, as I stepped out into the crisp autumn air, I noticed a young woman standing nearby, her fiery red hair catching the pale sunlight. She was dressed in a sleek black leather jacket, dark jeans, and worn combat boots. An intriguing contrast to the genteel surroundings. She introduced herself as Emily Hawthorne, the same young astrophysics enthusiast who'd emailed me weeks earlier. I've been following Sutton's story, she said, eyes bright with curiosity. It's like the universe handed us a puzzle wrapped in mystery. I want to understand it, to find out what it really is. Her passion was contagious. I realized that Sutton's true legacy might not be in the answers it gave, but in the questions it inspired. As I watched Emily disappear down the cobbled lane, I couldn't help but wonder, was Sutton the start of a new chapter in our cosmic understanding? Or just the first act in a play whose ending we couldn't yet imagine? And somewhere beyond the stars, another visitor was coming, silent, swift, and no less mysterious. The evening sky over the small coastal town of Dover was painted with streaks of orange and purple as I settled into the observation deck of the Kent Astronomy Center. The salty breeze tugged at my jacket, and the rhythmic crash of waves against the chalk cliffs provided a haunting soundtrack to the night's vigil. Tonight, the focus was Sutton's brightness surge, the ninth anomaly that had left astronomers baffled. Dr. Laura Mitchell, a sharp-witted astrophysicist with a penchant for colorful scarves and a mischievous smile, was already setting up the high-powered spectrometer. Clad in a fitted navy sweater, tailored trousers, and sleek leather boots, she moved with the confident grace of someone who thrived in both the lab and under star-studded skies. "Ready to chase some cosmic fireworks?" she teased, glancing over her shoulder. I chuckled. After Sutton's track record, I'm bracing for the unexpected. As the instruments hummed to life, Laura explained the anomaly. Near perihelion, Sutton brightened faster than any comet we've ever recorded. Not just fast, dramatically fast. And the color shifted toward blue, which is downright unusual. Most comets reflect sunlight with a reddish tint due to dust. But Sutton? It was bluer than the sun itself. She adjusted the spectrometer, eyes glued to the data streaming in. This suggests the particles or gases around Sutton scatter light in a way we don't fully understand. Either it's made of something exotic, or there's an unknown process at play. I leaned closer, trying to suppress my excitement. So, it's not just breaking the rules, it's rewriting them. Laura smiled. Exactly, and that's what makes this so thrilling. Sutton isn't just a cosmic curiosity. It's a challenge, a dare from the universe to look deeper. As the night deepened, we tracked Sutton's faint glow, watching as it faded into the darkness. But even as it disappeared from our view, its strange blue shimmer lingered in my mind. Walking back along the moonlit cliffs, I thought about the comet's impossible brightness and color, like a cosmic lighthouse flashing a secret signal. What was Sutton trying to tell us? And why now? Somewhere far beyond the horizon, another interstellar traveler was speeding our way, carrying its own secrets and anomalies. Sutton might have been the opening act, but the universe had many more stories to tell, and I was determined to listen. Late at night, in the cozy confines of my study in the historic town of Bath, the soft glow of my desk lamp illuminated stacks of research papers, spectral charts, and hastily scribbled notes. Outside, the rain tapped gently against the window panes, a soothing rhythm that contrasted with the storm of questions swirling in my mind. Tonight's focus was Sutton's mysterious sunward jet, the second anomaly that had scientists baffled and debating in hushed tones. I leaned back in my leather chair, fingers steepled as I reviewed the images captured by various observatories. Sutton was ejecting material not away from the sun, as physics would dictate, but toward it. Imagine a kite flying upstream against a gale and somehow gaining speed. Impossible, right? Yet there it was, documented and confirmed. The thought sent a shiver down my spine. What kind of mechanism could defy solar radiation pressure so blatantly? Outgassing in comets always pushes material away from the sun, creating their iconic tails. Sutton was doing the cosmic equivalent of spitting into the wind, and winning. A soft knock interrupted my thoughts. Emily Hawthorne, now a graduate student with a keen mind and an insatiable curiosity, stepped inside. She wore a fitted charcoal sweater and jeans, her presence both calming and invigorating. "Still chasing Sutton?" she asked with a knowing smile. "Always," I replied. "But this sunward jet, it's like Sutton's playing by its own rulebook." Emily pulled up a chair and spread out some recent simulation results. I ran some models testing various scenarios, rotational effects, localized jets, even magnetic interactions. Nothing fits cleanly. The jet persists, and the forces defy conventional physics. I sighed, rubbing my temples. If it's not natural outgassing, then what? Some kind of propulsion? But that's science fiction territory. Emily's eyes sparkled. Maybe that's where we need to look. Sometimes, the truth lies just beyond our comfort zone. We spent hours debating, questioning, and theorizing. The sunward jet wasn't just an anomaly. It was a challenge to our understanding of physics and nature itself. Sutton was forcing us to reconsider what was possible. As the clock ticked past midnight, I realized Sutton wasn't just a comet. It was a riddle wrapped in stardust, daring us to solve it. And as I looked out into the rainy night, I wondered, was Sutton a lone enigma, or the first chapter in a greater cosmic story we had yet to uncover? The dawn light filtered softly through the stained glass windows of the ancient chapel-turned observatory in the heart of Cambridge. I found myself seated at a polished oak table, surrounded by a small group of researchers, each engrossed in their own analyses but united by a shared fascination, unraveling the mystery of Sutton's trajectory, the first and perhaps most confounding anomaly. Dr. Alan Foster, a seasoned orbital dynamics expert with a penchant for tweed jackets and a dry wit, was leading the discussion. His graying hair was slightly tousled, and his sharp blue eyes sparkled with the thrill of the chase. He wore a crisp white shirt rolled up at the sleeves, revealing a leather strap watch that had seen better days. "Ladies and gentlemen," Alan began, tapping a tablet displaying Sutton's orbital path, "what we're looking at is nothing short of extraordinary. Sutton entered our solar system moving nearly opposite to the planets, yet almost perfectly aligned with the ecliptic plane. Statistically, that's like finding a needle in a cosmic haystack." He swiped the screen, highlighting the comet's close encounters with Mars, Venus, and Jupiter. And the timing, it's almost too perfect. Each flyby coincided with operational spacecraft nearby, maximizing observational opportunities. Yet, at perihelion, Sutton cleverly hid behind the sun from Earth's perspective, making ground-based observations impossible. I shook my head in disbelief. So, it's like Sutton planned its route, hitting all the right spots while avoiding prying eyes. Alan grinned. Exactly. Whether by chance or design, it's a trajectory that defies expectation. The room buzzed with cautious excitement. The probability of such an orbit occurring naturally was vanishingly small, around 1 in 500. But combined with the other anomalies, the odds became astronomically low. As the morning light grew stronger, the conversation turned to implications. Was Sutton a natural wanderer shaped by gravitational forces alone? Or was there something more? An intentional path charted for reasons unknown? I glanced around the room, catching the thoughtful expressions of my colleagues. No one had answers, but all were keenly aware that Sutton was rewriting the rules of celestial mechanics. Later, as I stepped outside into the crisp Cambridge air, I looked up at the sky where Sutton had once blazed a mysterious path. Somewhere beyond the stars, another visitor was already hurtling toward us, carrying its own secrets and challenging us to look deeper. The universe was speaking in riddles, and we had no choice but to listen. The chill of a late November night settled over the quiet village of Glastonbury, where the ancient mystery of the comet Sutton seemed to echo the timeless secrets whispered by the surrounding moors. I sat alone on the wooden bench outside the small observatory, wrapped in a thick woolen coat, staring up at the ink-black sky studded with stars. The final anomaly, the missing tail despite massive mass loss, was gnawing at me like an unsolved riddle. Physics was clear. Losing 4 billion tons of material in days should have painted a brilliant tail across the heavens. Instead, Sutton offered only a compact, fuzzy coma, an ethereal glow with no streaming debris. It was as if the comet had pulled off the greatest magic trick in the cosmos. Inside the observatory, Dr. Oliver Grant, a meticulous spectroscopist with a fondness for quirky bow ties and a dry sense of humor, was poring over the latest data. His glasses perched precariously on the bridge of his nose as he muttered, "Where did it all go? Vanished into thin air? I'd be impressed if it weren't so frustrating." I joined him, and together we reviewed the spectral signatures. No dust clouds, no fragments, just an eerie silence where chaos should have been. Oliver sighed. Each conventional explanation demands a special set of conditions. Dust lost as invisible gas? Viewing angle hiding the tail? Fragmentation too fine to detect? Possible, but stacking these improbabilities strains credulity. I nodded. 10 separate anomalies, each unlikely on its own. Together, The odds are less than 1 in 10,000. Oliver smiled wryly. Well, at least Sutton has given us job security. We sat in contemplative silence, the weight of the mystery pressing down like the fog rolling over the moors. Then, a message pinged on my tablet, an encrypted note from an anonymous source, hinting that Sutton might not be the last strange visitor, and that the secrets it carried were part of a larger cosmic puzzle. As the wind whispered through the trees, I realized the story was far from over. Sutton had slipped through our grasp, but its legacy was just beginning. And somewhere beyond, in the vast darkness between stars, another enigma was speeding toward us, ready to challenge everything we thought we knew. The first light of dawn broke over the rolling hills of the Lake District, casting a soft golden glow on the tranquil waters below. As I stood by the edge of Windermere, the weight of everything Sutton had revealed pressed heavily on my mind. The mysterious visitor was leaving our solar system, slipping back into the cold embrace of interstellar space, taking with it secrets we might never fully unravel. In the past months, we documented 10 anomalies, each one defying expectations, each one demanding we rethink our understanding of comets, of physics, of the universe itself. Sutton was no ordinary comet. It was a puzzle, a challenge, a whisper from the cosmos that our knowledge was incomplete. But as I gazed at the shimmering lake, a question lingered, sharp and insistent. What if Sutton wasn't alone? What if this was just the opening act of a grander cosmic performance? Around the world, telescopes were poised, algorithms scanning the skies, ready to catch the next interstellar visitor. The Vera Rubin Observatory was soon to come online, promising to uncover dozens, maybe hundreds, of such wanderers in the years ahead. Each would bring its own mysteries, its own stories written in stardust and motion. I thought of Emily Hawthorne, now a rising star in astrophysics, inspired by Sutton's enigma to chase the stars with renewed passion. I thought of the countless scientists, amateurs and dreamers who would look up, ask questions, and push the boundaries of understanding. And somewhere, far beyond our reach, I imagined another object hurtling toward the sun, its trajectory unknown, its nature a secret. Sutton had taught us that the universe doesn't owe us answers. It challenges us, teases us, forces us to confront the unknown with humility and curiosity. As the mist lifted from the lake, I felt a quiet resolve. We would keep watching. We would keep questioning. Because in the vast darkness between stars, where mysteries outnumber certainties, the next visitor was already on its way. And when it arrived, we would be ready.